Hello students, welcome to Sri Jayendra's Ring Zone classes. I'm your friend and mentor for coming classes with respect to physics. This is lecture number 2 of a unit System of Particles and Rotational Motion. Let's begin with today's class. In today's class we were discussing motion of the center of mass. In the previous class we were discussed the center of mass, how that could be identified, how that could be calculated, and everything about the center of mass. So today we are going to discuss about the motion of a center of mass. So let's just begin. Initially we will find out the velocity of cm. It's a velocity of center of mass. Let's just understand that a system of n particles of masses m1, m2 up to mn with position vectors of r1, r2 up to rn respectively. At any instant of time t, the position vector of the system RCM, it's a position vector of center of mass, can be written as that RCM, that would be is equals to m1 r1 plus m2 r2 up to mn rn divided by m1 plus m2 up to mn. Now when I add this m1 plus m2 plus mn, that would be the total mass of the system. So this RCM could be written as m1 r1 plus m2 r2 up to mn rn divided by total mass m. So as the time changes, the values of the r1, r2 and rn, yes, they are going to be changes. So if this r changes, we understand that position vector of center of mass even it changes. So it means that the velocity of center of mass of the system changes, and that could be written as vcm is equals to d by dt. It's a differentiation of position vector of rcm with respect to time. This will give me the velocity of center of mass. So we can write like this. It's a vcm that would be equals to 1 by m into m1 d by dt of r1 plus m2 d by dt of r2 up to mn into d by dt of rn. When I write d by dt of r, that can be written as v1, d by dt of r2, it's a v2, and d by dt of rn, it's a vn. So if I write like this, what I'm having is that vcm, velocity of center of mass, could be written as this is 1 by m into m1 v1 plus m2 v2 up to mn vn, and that would be equals to sigma mi vi divided by m. So this vcm, a velocity of center of mass, could be written as it's an m1 v1 plus m2 v2 up to mn vn divided by m1 plus m2 up to mn. While writing this, we must be very clear that this is the vector quantity. We are not finding out the speed of the center of mass. We are looking for the velocity of center of mass. And while I talk about the velocity of center of mass, or while I'm talking about the velocity itself, it means I'm looking forward to a vector quantity. And when I say it's a vector quantity, it must be having every possible respect that any vector should deserve it. Yes, I repeat it. When I will calculate a VCM, I will always look for the magnitude as well as direction. Here it is the situation where we made a mistake and the calculation would gone the wrong and the answer would not be there. So please do understand this, that this is the vector, these are not the scalars, and we must respect its magnitude as well as direction. Got it? Great. Now let's just look at the momentum of center of mass. So velocity of center of mass of a system containing n particles can be written as it's a VCM is equals to m1 v1 plus m2 v2 up to mn vn divided by m, where m is the total mass of the system. So if I write this, it's an m into VCM that could be written as m1 v1 plus m2 v2 up to mn vn. But what m into VCM is all about? It's in a reality center of mass, or I should say it's a momentum of center of mass. So this is the linear momentum. It's a linear momentum of center of mass of the system. So if I write down, it's a PCM, that would be equals to m1 v1, which could be written as p1, m2 v2 could be written as p2, Mn Vn could be written as Pn. So this is P1 plus P2 up to Pn, and this could be written as sigma Pi. This is this is the total linear momentum of the system. So this sigma Pi is equals to m into Vcm. Have you got this? Have you? Are you sure? Any doubts? No? Let's calculate the acceleration of center of mass. So we have this for n particles. For n particle systems, the position of center of mass was given as it's an RCM is equals to m1 r1 plus m2 r2 up to mn rn upon 1 by m. From this we have derived the velocity of center of mass. How? By differentiating. Yes, if I differentiate position vector with respect to time, I will be having an velocity. A same thing I will do with the acceleration, that I am going to differentiate velocity with respect to time. So let's just check it out, that Vcm was, it was m1 v1 plus m2 v2 up to mn vn divided by m. Yes, this is the velocity of center of mass. So when an external force acts on the system, a change in the velocity of center of mass takes place. Yes, for this you must require external force. We are going to discuss about this in more detail, but at this position you must understood that external force is required to change the velocity of center of mass. That means if only internal forces are acting on the system, I repeat, if only internal forces are acting on the system, then there would be no change. There would be no change in the velocity of center of mass or position of center of mass. Yes. So if external force is acting on a system, that can change the velocity of center of mass, and if it can change the velocity of center of mass, that means it can produce acceleration in the center of mass of the system, and that acceleration of center of mass could be given as ACM is equals to d by dt. It's a differentiation of velocity of center of mass with respect to time. Got this? Yes. So it's an ACM which could be written as m1 dv1 by dt plus m2 d by dt of v2 up to mn d by dt of vn into 1 by m. While write this, this could be the ACM is equals to m1 a1 plus m2 a2 up to mn an upon 1 by m. I hope this is clear. Is it clear? So, have you written the ACM? Have you written the formula of ACM? If not, please do write it. Please do write this. Have you written it? Are you sure? Are you? Great. Now also write down the formula of VCM. Please do it quickly. Did you written it? Have you? Have you written it? Great. So now, are you ready for the questions? Will you be? Will you be ready for the questions? Are you sure? Great. Let's look at the question. Let's suppose this is mass 1 having mass of 2 kg and moving with 10 meter per second in this direction. This is difference mass m2 4 kg moving with 20 meter per second in the same direction. What do they want? They want that find out VCM for the, it's a velocity of center of mass for the system shown in figure. Yes, so what I will write is, it is VCM, that would be equals to m1 v1 plus m2 v2 divide by m1 plus m2. As this is moving in positive x direction, this is moving in the positive x direction, so this could be written as 2 into 10 I cap plus 4 into 20 I cap divide by m1 plus m2. It's a 2 kg plus 4 kg, this is 6, so 2 tens are 20 I plus 420, it's a 80 I divide by 6. So this is 20 plus 80, it's a 100 by 6 I cap, and this would be equals to 50 by 3 I cap. This is velocity of center of mass. I hope this is clear. Is it clear? Is it? Are you sure? Are you sure? Great. Now let's look at this. Suppose the question says that a one object, it's an M1, let's suppose mass is 2 kg, moving with speed of 20 meter per second in this direction. And another object, mass M2, uh, let's suppose it's again 2 kg and moving with 30 meter per second, but in this direction. So the question is, find out VCM of the given system. So this is required. What they want the velocity of center of mass of the given system. So as you can observe, this is in the positive I cap, this is in the positive j cap, but I need to do a vector addition of this if magnitude is required. So let's just work for it and let's see what happens. It's a VCM that would be equals to M1 V1 plus M2 V2 divide by M1 plus M2. This is the master formula. So this could be written as 2 into 20. This is 40 I cap plus this is 2, this is 30. It's in j cap. So this is 60 j cap divide by M1 plus M2. This is 2 plus 2, 4. So that could be written as 40 by 4. It's a 10 I cap plus 60 by 4. It's a 15 of j cap. So if they want a vector only, this could be the answer. But if they want the magnitude of VCM, then I need to write this. It's under root of 10 square, it's a 100, 15 square, it's a 225. So this is root of 325 meter per second. I hope this is clear. Is it clear? Are you sure? So can this be done? Can this be done? Can it be? Are you sure? Great. Ready for the next question? Let's have a look to the next question. Suppose a first object having mass 1 kg and moving in this direction with acceleration of, let's say, 2 meter per second square. Another object having mass 2 kg having acceleration of, let's say, half meter per second square. The question says, find out ACM of the given situation. How will you do this? Will you going to add this or will you going to subtract this? That is only the question. So when I write this, I should understand that this is the vector and they should be having a respect of it. That ACM, that would be equals to M1A1 plus M2A2 divide by M1 plus M2. While writing this, I understood that this is 1 into 2 I cap minus 2 into 1 by 2 I cap. Yes, it is actually minus of I. Divide by, it's a 1 plus 2, this is 3 kg. So while writing down the ACM, this would be equals to 1 into 2, this is 2 I cap. 2 into 1 by 2, this gone, and it's a minus of I cap. Divide by 3, it's a 2I minus I, it's an I by 3. Yes, so this ACM, or I should say a magnitude of ACM, it's a 1 by 3 meter per second square. I hope you got this. Are you clear? Are you clear? So can this be done? Can it be? Can it be done? Are you sure? Great. Let's work for the next question. Let's look for this. It says that find out ACM, it's acceleration of center of mass of the given situation. So they have given one of the pulley system, and while doing this they have given that this is let's say 5 kg. This object is of 2 kg. Yes. So from the diagram I'm clear that this will be moving in this direction. Let's say this is A1, this is A2. So what ACM is, what is the ACM of this situation? So for ACM, what I need, it's an M1A1 plus M2A2 divided by M1 plus M2. This is all what I require. It's an M1A1 plus M2A2 divided by M1 plus M2. But for A1 and A2, for A1 and A2, what I need is I need to find out the acceleration, and that acceleration could be given as it's a 5 minus 2 into g divided by 5 plus 2. Yes, it's an m1 minus m2 divided by m1 plus m2 into g. So when I write this, it's a 5 minus 2, it's a 3 into g. This is 30 by 7 meter per second square. Yes, this is just the acceleration, and this is not the ACM. I have solved it for just the acceleration. I know that both are moving with the same acceleration, but their directions are opposite. So if any one of them is considered as a positive, the other one should be considered as a negative. So while I'm doing this, let's suppose I take ACM, this as a minus of I, minus of j, I'm sorry. It's a 5 multiplied by, it's a 5 multiplied by 30 by 7 of minus of j plus this is 2 multiplied by 30 by 7 plus j divide by total mass, it's a 7. So this is equals to 35 is a 150 by 7, or I should say minus of 150 by 7 j cap plus 32 is a 60 by 7 j cap divide by 7, and this could be written as this is minus 150, this is 60. So this would be a minus of 90 by 49, 7 sevens are j. This is the ACM required. I hope this is clear. Is it clear? Any doubts up till now? Is there anything? Is there anything? So will you capable enough to do this? Are you sure? Can we do this? Can we? Can we? Are you sure? Great. So now let's look for the one more question. A pulley is here. It's an M2. This is M1. And they want that find ACM. So first what you need to do is you need to find out the acceleration. How will you do this? Acceleration could be given as it's an m1g divided by m1 plus m2. Yes, both blocks, I mean m1 and m2, both the blocks are moving with the same acceleration, but the directions would be different. This is a for the m1, and as this block is moving downward, this m2 is moving forward. So acceleration of a is in I cap, and acceleration of m1, it's in minus of j cap. I hope this is clear. So let's just write it down, that ACM. How will you do this? It's an m1 into AC acceleration, it's an m1g divided by m1 plus m2 into minus of j plus m2 into bracket m1g divided by m1 plus m2 into I cap. This is to be divided by m1. This is to be divided by m1 plus m2. I hope this is clear. So this would be equals to m1 square g divided by m1 plus m2 into minus of j cap plus m1 into m2 into g divide by m1 plus m2 into I cap, divide by m1 plus m2. Got it? So this ACM could be written as that it would be m1 square g minus of j cap divide by m1 plus m2 whole square plus m1 into m2 to g divide by m1 plus m2 whole square into I cap. Let's write this as an a1 minus of j cap plus a2 I cap. Yes, this all has been replaced by a1 and this all has been replaced by the a2. So if I require the magnitude, I can write like this: it's a root of a1 square plus a2 square. Got this? Are you sure? So can you do this? Can you? This is the acceleration of center of mass that could be written as root of a1 square plus a2 square. Are you done? Have you? Have you done with this? Have you? Have you done with this? I hope this is clear. Is it clear? Is it? Yes. So can it be done? Can it be done? Are you sure? Great. This is the ACM. Now let's move to the next question. You are doing pretty good job. Well done. But keep this continue. So let's suppose the question is about that one object is there having mass 2 kg and this is moving in this direction with a speed of 20 meter per second. A second object is there. This is having a mass of again 2 kg. This is moving. This is moving with a speed of let's say 40 meter per second. Acceleration of this, it's let's say a2 is given, it's a 2 meter per second square. On this acceleration is given that is equals to 1 meter per second square. So the question is, listen it very carefully, find out distance traveled by COM. Find out distance traveled by COM before coming to rest. This is required. They says that find out the distance traveled by center of mass before coming to rest. This is required. So just take a time of 30 seconds and think what we should attempt to find out the distance of center of mass before it has been reached to the rest level. How will we do this? Any idea? Anything? What we are supposed to do? What we should do? So let's assume that if it was not about center of mass and forget all these things about center of mass, if it was only the initial situation of let's suppose any one of the object, then what I'm supposed to do is that when if let's suppose it is a talk of any one of the object, then what I'm supposed to do is it's a v square minus u square is equals to 2ax. Final velocity would be 0, initial may be given, it's a yes, it is absolutely given, 2 into, as it is retarding, negative is here and this is x, and that's why I will do this. So what I need to do is I need to write a same thing in a format of center of mass. I hope this is clear. So what I'm supposed to do is that let's look at this very carefully. This is vcm square, it's a final velocity of center of mass, minus it's a square of the center of mass but initial velocity, that would be equals to 2 into acm multiplied by xcm. So the final velocity would be a 0, yes, because it is coming to rest, minus of u square center of mass, this is equals to 2 into, and as this both are moving in the negative x direction, this is minus of acm multiplied by xcm. So what you need to do is you need to find out the UCM and you need to square it identically. Then you need to find out the ACM. Yes, and if you can able to solve this too, then you will have an XCM. I hope this is clear. Yes, is it clear? So let's do it one by one. That means the 2 kg object moving with 20 meter per second, retarding force in this direction 1 meter per second square. Another object, another object having mass of 2 kg moving in this direction with a speed of 40 meter per second, and retarding force is in this direction, it is 2 meter per second square. So UCM could be written as m1u1 plus m2u2 divided by m1 plus m2. So this is equals to, it's a mass 1 into u1, it's a 2 2s are 40 I cap, plus this is 2, this is 40, it's an 80 I cap, divide by m1 plus m2. This 2 plus 2, it's a 4. So this is equals to 10 I cap plus 20 I cap divide by 4, which is equals to 10 plus 20, it's a 48, it's a 120 by 4, it's a, yes, it's a 30 I cap, it's a 30 I cap. I hope this is clear. Is it? Yes, it has, when it has been divided already. So it's a 10I plus 20I is equals to 30 I cap. Yes. Now let me just calculate the ACM. This is equals to m1a1 minus I plus m2a2 minus of I divide by m1 plus m2. While doing so I am about to write this is 2 into 1 minus of I plus 2 into 2 minus of I divide by m1 plus m2. 2 plus 2 4. So this is minus 2I, this is minus 4I divide by 4. This is equals to minus of 6I by 4, and 6 by 4, it's a minus of 1.5 I cap. Now you are having an UCM, that means you are having an U square, you are having an ACM, and let's just do this. It's a VCM square minus of UCM square is equals to 2 into ACM multiplied by XCM. So this should be a 0. Initial velocity, it's a 30, so it's a square of it, it's a 900 is equals to minus of 2 into A, it's a 1.5. I can write like this, it's a 3 by 2 into XCM. So this has gone, minus has gone, so the XCM would be 900 by 3. This is equals to 300 meters, let's say. Yes, so this could be done, this could be done. I hope this is clear. So what you need to think is that you need to behave it initially, while think that what should I do. Yes, to make a strategy you need to understood that this can work as a single body. While you write a CM, it's a center of mass, that means you are going to replace the complete system by a one individual particle which is having all the masses, which is having all the velocities, which is having all the acceleration acting on it. I hope this is clear. So whatever you were doing or whatever we were attempting in the unit number 3, which is motion in a straight line, or let's say motion in a plane, or let's say laws of motion, that all things are allowed here as well. Only the difference is when we attempt it over there, it was just the complete object, and here it is the combinations of the objects that we call as in, here we are going to apply this on a system. That is only the basic difference between these two. I hope this is clear. Is it? So let me add something for you guys that you are going to attempt it. I am not going to do it this. The question says that find out time taken by COM before coming to rest. Yes, you need to find out the time required to come to rest. What you are supposed to do is, let me give you the hint. What you are supposed to do is, it's a VCM minus UCM is equals to ACM into T. That's it. Now you know this better. Got this? Did you? So can we assume that this can be done? Can I assume that? Or are we pretty sure that we will do this? Are we? Can I assume that this will be done for sure? Great. Now let's look at the one of the very good conceptual question. Let's understand the situation. This is one of the object. It has been projectile and mass of this is 2 kg. Its a velocity, let's say 30 meter per second, and this theta, it's a 30 degree. Here it's an another object. It is its mass, let's say again 2 kg. Its a velocity 60 meter per second, and this angle is 60 degree. This is the situation. And what they want? They want that find out h max of center of mass. So they want the maximum height that can be achieved by the center of mass of the system. Our diagram is representing two objects, one having mass 2 kg, which has been projected with a speed of 30 meter per second while making an angle of 30 degree with the horizontal, while the other is there having the same mass. According to the mass, they are identical, but it has been thrown with a speed of 60 meter per second while making an angle of 60 degree with the horizontal. So what I need to do, I need to find out the h max of center of mass. So just take 15 seconds and tell me what can be done. Take your time. Yes, what do you think? What is to be done? So what I understood is that that should be the approach to do this. Let's first define it and then we will work for it. That it's an approach, that what I need to do. What I understand is that while calculating h max, what we are supposed to do is it's a vy square minus of uy square is equals to 2 into g into h. If I put vy as a 0, then it would be a uy square should be equals to 2 into g, or it should be a rather of minus of g multiplied by h max. So this h max could be is equals to uy square divided by 2 into g. So if I am supposed to do this, what I need to do this is that it's a vy square for center of mass minus uy square for center of mass is equals to look at this, it's g is here, it's g is here. When both the particles are having an acceleration in the same direction, it would be the g only. Yes, so this is 2 into g into h. If I put this as a 0, minus of uy square center of mass, this is equals to minus of 2 into g into h max, and this was about center of mass. So uy, or I should say initial velocity, in the vertical direction is responsible to calculate this. So what I need to do is, let's redraw the question. This was 30 degree, 30 meter per second. This was 60 meter per second and 60 degree. What I want this component. This is velocity of, or I should say initial velocity of first object. This is u1. This is u2. or uy1, and this is uy2. Now what you need to do is that this is cos theta component, that is 30 cos 30 degree. This is 30 sine 30. Again the same thing. This is 60 cos 60. This is 60 sine 60. So what you need to do is this UCM, this is equals to M1 U1 plus M2 U2 divide by M1 plus M2. This mass 1, it's a 2 into 30 into sine of 30 degree j cap plus M2, it's a 2 into 60 into sine of 60 j cap divide by M1 plus M2. So this is 2 plus 2. This is equals to 4. I hope this is clear. Is it clear? Is it? Are you sure? Great. Now, what is UCM over here? This is 2 into 30. It's a 60 into half j cap plus 2 into 60. It's a 120 multiplied by root 3 by 2 j cap divide by 2 plus 2 4. It's a 60 by 2, which is equals to 30 j cap plus 120 by 2, it's a 60 root of 3 j cap divide by 4. So this is 30 by 4 plus 60 root 3 by 4, which is 15 by root 3 j cap. This is UCM. I hope this is clear. Is it clear? So what you need to do is it's a Vy square Cm would be equals to 0. So this H max of center of mass, this is equals to H max of center of mass, this is equals to Uy square of center of mass divided by 2g. I hope this is clear. Yes, so get the data, put up the value and get it done. Yes, this can be done easily. 30 by 4 is a 7.5 and 15 root 3 is 1.73. Yes, so try to solve this. I hope this is clear. Is it clear? Is it? Okay, great. Shall I add something to this question? Shall I? Let's have a look. So the question says that in the previous question, find out range of COM. You need to find out the range of the center of mass. How will you do this? How you are supposed to perform this? It was something like this. Let's say this is V1, this as a theta 1. Let's say this as a V2, this as a theta 2, this is M1, this is M2. How can we do this? How could we? What I assume, what I'm supposed to understood is that this range would be is equals to 2 into ux into uy divided by g. Yes, this was the normal situation. For calculating this for the center of mass, what I need to do this, I need to understand that this is center of mass. Yes, even g is the center of mass. Yes, it is only the g only. So what I know is that you have already calculated this. Only the thing that you required is the ux. I hope this is clear. Am I? Am I clear? Yes, only the thing that you required is the ux. So for the UCM in x direction, what you need to do is this is m1 u1 cos theta 1 I cap minus. Why minus? Because it is moving in this direction. This is equals to minus of m2 u2 cos theta 2 I cap divide by m1 plus m2. Yes, you need to perform this, that it's an m1 u1 cos theta I cap minus m2 u2 cos theta 2 I cap divide by m1 plus m2. Once you do this, put up the value and get it done. Yes, I know this is a typical question, as well as this required a longer amount of calculations, but does it clear according to the approach used in it? Yes. Does it have positive impact on you? Great. So let's just wind it up the session over here. This is the part 1 of the motion of center of mass. In the next session we will begin with certain more concepts, but I want that before you tune into that, you must go through all the things that we have done up till now. That means center of mass and motion of center of mass. Please revise this very carefully. Please do not forget to attempt at least 10 to 15 questions of center of mass, which were which was discussed in the last class, because once we have a command over it, it will be with us for 11th and 12th, and this is required. So please revise this, as well as now also start doing the questions of the motion of the center of mass. This can be done for sure. Please revise it, please do it. This is the requirement of engineering or medical examinations. Yes, thank you, have a good day, take care, bye bye.